On a whiteboard, every architecture looks perfect. The boxes connect, the arrows point the right way, and everything promises to scale. But when I sit down for a system design review, I'm not looking at the boxes. I'm looking at what's between them, because those invisible spaces are where systems die in production. To most people, this diagram looks correct. But let's run it through the 5 architecture red flags I look for every single time. Red flag number 1, the synchronous trap. Here, every service calls its dependencies over a synchronous REST API. On the whiteboard, it looks organized, but in production, synchronous means coupled. When inventory takes 3 seconds to respond during traffic spike, every upstream service hangs, timeouts cascade, and the user stares at the spinner. The fix is to match communication to intent. Use REST or gRPC for queries that need immediate answers, but use asynchronous events through message brokers for state changes. And design every handler for idempotency because in a distributed system, messages will arrive more than once. Red flag number 2, the God database. Many services pointing at the same monolithic database. Same schema, same bottleneck. One team runs a heavy database migration and every other team's queries break. The fix is domain ownership. Each service owns its data using bounded contexts. You separate reads from writes using CQRS, and you accept that eventual consistency is a deliberate design choice, not a compromise. Red flag number 3, the distributed monolith. The team split the application into a dozen containers and called it Microservices, but they share the exact same release cycle and the same deployment pipeline. Update one, you update all. They bought the complexity of distributed system with none of the independence. Real decomposition requires independent deployment. It requires contract testing between services, so version mismatches are caught in CI, not in production. More services is not more architecture. It is just more coordination cost. Red flag number 4, the crunchy shell software center. From the outside, it looks hardened, WAF at the edge, authentication at the gateway. But inside the cluster, every service trusts every other service implicitly. One compromised container, and an attacker could move laterally across your entire network. Zero trust means exactly what it says. Verify every call. You need mutual TLS between services. And you need attribute-based access control because context is where privilege escalation hides. Red flag number 5. The blind cascade. Your payments service is a third-party dependency. It will go down. In this design, when it slows, your checkout service keeps calling, threads exhaust, and your platform crashes. But worse, because there is no telemetry, your engineers are completely blind. They have no idea where the fire started. The fix is failure isolation and deep observability. You need circuit breakers and bulkheads to contain the blast radius. You need retries with exponential backoff and jitter. Otherwise, infinite retry loops turn a partner's slowdown into a self-inflicted denial of service. And you need distributed tracing baked in from day one. Now let's zoom out. The architecture is hardened, decoupled, observable, and secure. But let's be honest, there is no such thing as a universal best practice. Every fix we just applied was a trade-off. You want low latency? You pay with eventual consistency. You want 5 nines of uptime? You pay with operational complexity. CAP theorem isn't a succession. It's the physics of distributed systems. You cannot have strong consistency and high availability during a network partition. On a whiteboard, every architecture works. The architect's job isn't to draw a perfect diagram. It's to know where the diagram is lying and to make every invisible decision visible, documented, and deliberate.